Hello and welcome to Honors Function. This is a second video on intervals of increase and decrease. In this video, we're going to be working with word problems. You will be given a word problem, and in this problem, you will be asked to find either the max or the min of a quantity. The whole question will be to find the model for the quantity model, and that's going to be a function. In this set of notes, the function will always be quadratic. Okay, quadratic. So what does it mean to find the max and the mean? Well, there are two types of quadratics: the quadratic function that are concave up and the quadratic functions that are concave down. Therefore, finding the max or the means simply means to spot the vertex of the quadratic. Sometimes in the problem you will have to answer with the x-coordinate of the vertex, figuring out what that means. Okay, so we're gonna have to pay attention to the units in the problems here. What do you plot on the x-axis? Or sometimes finding out the y-coordinate of the vertex to find out something else. Okay, and again here you will want to know what you're plotting. Okay, so what is this function f? What are you plotting here? Okay, and then don't forget at the end you will have to answer the problem. Okay, so you always answer a word problem with a sentence. Okay, with a sentence. Don't just give me a word. It has to have a sentence, and of course you're gonna need some units to answer. So pay attention to the units in the problem. That's very important. Let's go with the first example. There are 6 examples. I'm gonna do 3 and I'm gonna let you do the other 3 examples. Okay, let's start with the first one. Example 1. On a certain route, an airline carries 8,000 passengers per month, each paying $50. I'm circling the numbers. I'm guessing they're gonna play a role in my problem. Okay. A market survey indicates that for each dollar increase in the ticket price, the airline will lose 100 passengers. Find the price of the ticket, price. Well, find the price of the ticket, okay, that will maximize the airline's monthly revenue for the route. What is the maximum revenue? Alright, so the first thing I see right here is rereading the last 2 questions. I am asked to find the price, so I need to find a price that will maximize the monthly revenue. Okay, so this is what I want to maximize. I want to maximize the monthly revenue. Therefore, I'm going to have to model the monthly revenue. What is the model for the monthly revenue? Well, I'm going to be using labels that we use in econ. So in econ, price is denoted by lowercase p, revenue is denoted by capital R, revenue, and quantity of an item sold, quantity of passengers, quantity of tickets. Generally a quantity is noted by lowercase q, okay, and that's for here in the problem it's going to be the number of passengers. Okay, how do we model the revenue? How do you compute a revenue? A revenue is the number of passengers, okay, so it's Q times the price of a ticket, right? This is what you will get from selling Q ticket at P dollars, right? You're gonna get Q times P. All right, we want to maximize this function. How do we do it? Well, there are 2 variables here. If I want to maximize this function, I'm going to have to turn it into a 1 variable function. Let's read the beginning of the problem. On a certain route, an airline carries 8,000 passengers a month, each paying $50. So in this with this information, the price is fixed, right? It's $50. P equals $50 right here. But we're looking for a price. So actually my price is not really fixed. This is just a base number I'm dealing with here. A market survey indicates that for each dollar increase in the ticket, the airline will lose 100 passengers. So this is the main thing in the problem. There is a relation between the ticket price, between P and Q, right? If P increases, if you increase the ticket price, Q will decrease, okay? This is in econ, they call that the demand equation actually, okay? Demand equation. And this is what we need to find right here. So how do we find the demand equation? Q the number of tickets I'm selling is a function of the price. I need to find this function. So how many tickets am I selling? Well, I know for $50 I'm selling 8,000 tickets. So before we tackle this question to finding Q, let's get a couple of numbers here. If my price is $50, I'm selling 8,000 tickets. And then for every dollar increase, so if my price goes to $51, if my price goes to $52, okay, how many tickets am I selling? Well, the airline will lose 100 passengers. So here I will be selling 7,900 tickets. Here I will be selling 7,800 tickets. Okay, you see what I mean? So the number of ticket is a function of the price. Now let's try to get this function. This function is actually linear, right? If you increase by 1, you decrease by 100. This is very, very linear, right? Input, output, okay? Change in input, change of output, they're all the same here. So how do you find this function? Well, you can take 2 points and find the linear function that goes through it, or we can do it a little bit more directly. Let's start with our base number. The base number is 8,000 passenger. What happens to this number when the ticket price increases? This number goes down. This number goes down, right? So that's why I'm putting a subtraction right here. It goes down by how much? By 100, or by 200, or by 300, okay? So it goes down by a multiple of 100. And how many 100? Well, it depends, 1, 2, or 3, so it depends of your ticket price, right? Look here. If the ticket price increases by $1, I'm going to lose 100. If I increase by $2, I'm going to lose 200. So how do we write this? The ticket price is P, and P is equal to 50, actually 50, 51, 52, 53, right? And what I want to multiply, when I want to multiply 100 by, is here it would be 0, here it would be 1, here it would be 2, here it would be 3. If the ticket price is $53, I need to multiply 100 by 3. So how do we find this number right here? Well, that's just P minus 50, right? The price, 53 minus 50. The difference between the price and 50 right here, okay? So this is my demand equation. Let's clean it up a little bit. So we have 8,000 minus 100 P plus 5,000, right? So it is negative 100 P plus 13,000. This is the demand equation. Q equals Q of P, okay? It doesn't matter. All right, let's get back to our revenue now. I can write my revenue as a function of the price, and the revenue will be, so the revenue is, I'm going to write it here, the revenue is, so P times Q, right? P times Q, so it is, I need to multiply P by this expression, negative 100P plus 1,300, right? Okay, 13,000, sorry. So what do we have here? We have negative 100P squared plus 13,000. Right here, and this is our revenue, and this is the model of the problem. As I said, it's a quadratic model. All right, before we finish answering the question, let's check out the graph of this quadratic equation. So look, on the y-axis you will plot the revenue, on the x-axis you plot the price. Now what is the y-intercept? Oh, you gotta distribute here. There's a P right there, okay? It's 13,000 times P. If P equals 0, Y equals 0, makes sense, okay? If the price is 0, you're not gonna get any revenue. And the parabola is concave down. It's concave down like this, right? So there will be a price that will maximize the revenue, okay? There will be a price that will maximize the revenue. We just need to find it, so let's go fetch it right now. I'm gonna complete my square. I'll do it right here. So R divided by negative 100 equals, so it's P squared minus 130 P, right? Okay, so let's complete the square right now. So we have P minus half of 130, that's 65 squared, and then minus 65 squared, and that is 4,225. Use a calculator, of course. So we have R equals negative 100 times p minus 65 squared plus, right, you multiply by negative 100, so that turns it into a plus, 42,000, no, let me see, let me write the number first, I had 20 there, 422,500, okay, 422,500. So let's answer the question now. So for a price, it's not the maximum price, right? It's not the maximum price. The price can be as high as you want, but for a price of $65, the revenue will be maximum at, so what's the maximum revenue? You read the y coordinate at $422,500. Okay, that's it. First problem. All right, let's move on to the second problem. Okay, so this is a typical problem of tree growing on an acre. When you have 14 apple trees on an acre, per acre of a certain orchard, the average yield per tree is 480 apples, okay, each year. Okay, so this is what's going on here. Let me do a quick drawing of what's going on. You have an acre right here, right? Let's suppose that's an acre right there. And you have apple trees growing on the acre right here. Here's one apple tree. Here's another one apple tree. Here's another one right there. And then here's, okay? So you have apple trees growing on an acre. All right. When you have 14 apple tree, every tree will give you 480 apples each year, okay? 480. Now, let's keep on reading the problem. I think this is clear right here. I have a pretty clear idea of what's going on. When I have 14, for each additional tree planted, so here, let me bring a new one, and this one will be blue, right here. Here's an additional tree. For each additional tree planted, the annual yield per tree decreases by 10 apples. What's going on here? Well, this tree is going to be taking some resources from the ground to grow, right? And therefore, all of the other tree will produce less apple on average, okay? So if you add one tree, they will all produce 570 apple, okay? 570, and this one will be 570, all right? So they all go down by 10 apple for each tree added. So this is like the demand equation we had in the previous problem, right? All right. How many additional trees should be planted in the orchard so that you maximize the number of apple produced per year? The number of apple on the orchard, okay? So we want to maximize the number of apple on the orchard, what the yield on the orchard. So I'm gonna have to introduce some label here. Let me call yield on the acre. I'm gonna call YA yield on the acre right here, yield on acre, okay? Let me say that YT is the yield per tree, okay? The yield per tree right here. Then the number of tree, we'll still call it Q. This is kind of typical, right? As I said before. Q number of trees. And now let's see, what do we want to maximize? We want to maximize the yield on the acre. We want to maximize this. We have to maximize this. So what is the yield on the acre? Well, that's pretty simple, right? You take the yield per tree, right? Every tree produces how many apples, and you multiply by the number of tree on the acre. This is a function that you want to maximize. Therefore, we need to figure out what's the yield per tree. All right, so yield per tree. Okay, what does the problem say? The problem says that if you have 14 trees on the acre, each will produce 480 apples a year. And then for each additional tree, you're going to have 10 less apples. So the base number here is the yield per tree. The base number is 480 apples, okay? And then this number is going to go down by a multiple of what? By a multiple of 10. By a multiple of 10, okay? Now, what multiple of 10? Well, let's see. Q can be what? Q can be 14, 15, 16, 17, right? If Q is 14, you don't want to take away any 10 right here. The yield is 480. If Q is 15, then you want to take away 110. If Q is 16, you want to take away 2 10s. Okay, the yield will be 460. If Q is 17, you want to take away 3 10s, and the yield will be 450. All right. So basically, you want to take away the number, the difference between Q and 14 right here, right? This is what you want to take away. All right, so let's clean this up. It's 480 minus 10 times Q plus 140 right here. And so we have Y of t is equal to negative 10Q plus 620 right here. All right, now what's going on here? We need to maximize this function, so let me multiply by Q. So right away, I'm going to do it right away. We have YA equals, so negative 10Q squared plus 620Q. Here we go again. This is a quadratic. It's concave down. It has a local max. Let's find, actually it's an absolute max here. Let's find it. Let's divide by negative 10. So we have Q squared minus 62Q. So let's complete the square. Q minus 31 squared minus 961. And finally, let's get back to YA. So YA is, so negative 10 times Q minus 31 squared plus 9,610. Here we go. This is YA right here. All right. So let's answer the problem now. Okay, don't forget, let's answer the problem. If you plant 31 trees on the acre, the yield, the annual yield will be maximum at 9,610 what? Apples on the acre every year. Okay, that's it. All right, let's do the last example, example number 5. So what do we have here? We have a company that prices their 5-finger. I don't know if there's an S or not at 5 fingers. Hey guys, if you don't know what that is, please Google it. 5-finger. Okay, it's a type of shoes. You've all seen it. They price their 5-finger at $85, and they sell 55,000 pairs of shoes a year. Okay, so if it's 85, you're selling 55,000 pairs of shoes. A market survey indicates that for each dollar increase, it will sell 1,000 fewer pair of shoes. Pair or pairs? I don't know. I'll see. Moreover, it costs the company $50 to make one pair. So now we have the cost that is introduced. Okay, what price will maximize the profit? This is a very typical problem in econ. You want to maximize your profit. Okay, you don't want to maximize the revenue. You need to maximize the profit. In the first problem, we were selling tickets, right? Plane tickets. We were missing the cost to have a passenger taking the plane. There's cost that you have, you know, cleaning the plane and the gas and everything, right? So we are mixing the cost to maximize the profit. All right, so this is a little bit more realistic. We want to maximize the profit. Okay, the revenue, we saw the label, it's R. The cost in econ, they call it C. It's all capital. The profit, now the profit is not P, right? Because we use lowercase p for the price. The profit is pi. Okay, they use pi in econ for profit. So we want to maximize the profit. All right. So how do we do that? That's a function we keep in track of, and we need R and we need C. R is the number of shoes that you're selling, Q, times the price of a pair of shoe, times P, right? C is the number of shoes I'm making. Well, this number is we're going to assume it's the same as the number of shoes you're selling, right? It's Q times what it cost me to make one pair of shoes, and that is $50. Okay, it cost me $50 to make a pair of shoes, so I need to multiply the number of shoes I'm making by 50. Okay, let's go find R and C, and for that we need to determine the quantity in function of the price. We need to determine the demand equation. This is what in econ they call the demand equation. Okay. All right. So what's our demand equation? Okay. So let's get Q. So what is the number of pair of shoes that you're making? Pairs of shoes. You start with 55,000. You start with 55,000, and this number is gonna go down by a multiple of 1,000, right? Every time you increase the price by $1, it goes down by 1,000. So, and here you need to figure out how many dollars you've increased the price by. The price is P. P is, it's 85, it's 86, it's 87, okay? So you increase by $1, you increase by $2. How are you gonna find the increase? You take the price and you subtract 85. The difference between the price and 85 is the increase from 85, right? Okay, so let's figure out what these numbers are. So we have 55,000 minus 1,000 P plus 85,000. So it is, so Q is negative 1,000 P plus what? 85 and 85, 140,000 right here. Okay. All right. So now that we have Q, let's write our revenue. So what's a revenue? The revenue is P times Q. So it is, I'm going to multiply this by P. It is negative 1,000 P squared plus 140,000 P right here. What's the cost? The cost is 50 times Q, right? The cost is fixed for every shoes. I need to pay $50 to make them, right? So it is 50 times this. So it is negative 50,000, negative 50,000 P plus, and if you multiply this by 50, you will find 7 million. 7 million right here. All right. So let's get the profit now. The profit is, so R minus C. So it is R, negative 1,000 P squared plus 140,000 P minus C minus negative 50,000 P plus 7 million right here. Okay. So what is this? This is negative 1,000 P squared. This is pi, negative 1,000 P squared. So this is a plus 50 and 140, 190 plus 190,000 P right here. And then minus 7 million. Here we go. This is my model. This is the profit equation. Okay. Let's quickly check out the graph of the profit equation. We don't have to do that, okay? But I want to check out what it looks like. Let me look at the number. Okay. So here's my graph right here. On my x-axis, I have P. On my y-axis, I have my profit. So you start right here at negative 7 million. Why do you start at negative 7 million? We'll see. And then it goes up like this. And then it's going to go down because it's concave down, okay? All right, let's look at this number right here. Okay, so negative 7 million is probably what you have to pay before you start selling anything, all right? Now, if you sell your shoes for this price, you're never going to make a profit. This is way too low. You're not going to make a profit. If you sell these shoes for this price, you're not going to make a profit. People are going to buy them, but you're going to lose money because it costs you too much money to make the shoes, right? This is the price at which you will first, well, actually right here, the profit is 0 right here, okay? So the profit is 0 right here. We call that the break even. This is a break even point right here. So figure out the price right here to break even, and then any price above that you start making a profit. At this price right here, it is so expensive that people will not buy any shoes, and that's why the profit would be like 0. Okay, so what we want is find this price to figure out what profit is there. So we need to complete our square. Let me look at the number, negative 1,000. Okay, all right. So here we go. We have pi divided by negative 1,000 equals, so P squared. So that's going to be a minus 190p, right? And then minus, plus, is it a plus or minus? It's a plus, right? It's a plus, 7 million, so it's 7,000, right here, plus 7,000. So we have p minus 95 squared minus 9,025 plus 7,000. So this is minus 2,025, and so therefore pi is negative 1,000 times p minus 95 squared plus, so plus 2025 and 30, and this is $2,025,000. Okay, I'm gonna let you write the sentence right here. The video is already too long. For $95 a pair, you will maximize your profit at $2,025,000. Thank you for watching.